All right, this is AP BC Calculus. This is a BC only video. We are doing Unit 8, Section 13, which is the last section in Unit 8, and it's arc length. So let's go ahead and get started. So what is arc length? So basically, if you were to trace some curve, right, so this is my y equals f of x from some x equals a to x equals b, the amount of string that it would take, right, to trace the curve, so if you were trying to line this thing with a piece of string, right, did a terrible job, but you get the gist. That thing I just highlighted in blue, that would be the arc length from A to B, right? It would be the amount of string that it would take to trace the curve exactly, right? So to understand the arc length formula, which we should understand because you will tend to do better on things if you aren't just memorizing them, but if you're sort of getting why they work in context, we basically need two things we already know how to do. We need Pythagorean theorem and we need integration. So let's zoom in on this tiny little chunk, and we're going to say that this piece, right, this piece of the curve, this little is this hypotenuse here, right? And we're going to use S for arc length, okay? So this ds is a tiny little chunk of arc length. And if we make a little right triangle here, there's a tiny change in x and a tiny change in y that would act as the legs. So there's this infinitely small piece of arc length, and it doesn't look infinitely small here because I zoom way in, but it's super duper duper tiny. So we can basically consider this small section linear, right? And we can recognize that because of Pythagorean theorem, ds, that tiny change in s quantity squared, equals dx squared plus dy squared, because Pythagorean theorem. And we can square root to solve for ds. Since arc length is a scalar, it can't be negative, right? It's a scalar. It's what length of string you would need. There's no positive or negative. We don't need the negative in front of the square root, right? So we just need the positive version. All right. So we now have this ds equals the square root of the quantity dx squared plus dy squared. All right, so if we want to solve for s, the arc length, we would integrate, right? So if I integrate both sides, the integral of ds equals the integral of this ugly root, right? Note that when I integrate ds, I just get s, right? And we're not worried about the constant of integration because one of the things I want to point out here is that when you do arc length, you don't do arc length without bounds. The arc length is between two values. So while this work is without bounds over here, my arc length formula is going to have bounds. It's going to have an a and a b for x or a c and a d for y. So, and those letters are sort of arbitrary, but those are the letters we usually use. So when I integrate ds, I just get s, right? On this side, usually I have to have some variable of integration sitting out here on the outside. The way I get that variable of integration is by factoring out a dx squared. Okay, so I'm going to factor out a dx squared and pull this out here. So factor out a dx squared, that means I have to divide by dx squared and divide by dx squared. So I'm going to get that I have s is the integral of the square root of dx squared over dx squared, which we'll deal with in a sec, plus dy squared over dx squared, and then with respect to x. Well, if I clean this up, this guy is a 1, which you can see here in this formula, and this guy is a dy dx quantity squared, which would mean the derivative quantity squared. This is my arc length formula. So if I'm integrating from a to b, I'm integrating the square root of the quantity 1 plus whatever the derivative of the function is squared. And you'll see that if we have y as some curve written as f of x, you'll see that as f prime of x, right? So that's our arc length formula, right? That's it. You can straight up just memorize it if you want, but it's nice to know the context in case you get confused and you don't remember how it works. So again, it's a square root 1 plus whatever the derivative of the function is squared with respect to x. If we do this with respect to y, so let's go ahead and look at the next slide. If instead of factoring out that, so let's say I have things in terms of y, right? So things in terms of y. Instead of factoring out a dx squared, right, I would factor out a dy squared, and then it would be basically the same task, right? Instead of dividing by dx squared, I'd be dividing by dy squared. So I'm going to get that this is a dx dy quantity squared, which really just means the derivative of the function in terms of y, right, plus 1. Most of the time, since addition is commutative, right, we switch this around so it looks like the same formula that I had in the yellow box where it was 1 plus whatever the derivative squared is, right? So again, I have 1 plus whatever the derivative of the function is with respect to y, quantity squared, and then I integrate with respect to y. Notice that the y's are c and d here. It doesn't matter. That's fairly arbitrary. It was just to make the point that they are not the same value as the x and b, right? As the a and b. A and b are x's. The c and d would be the y values at the same point. Again, if your function was written instead of being written as x equals a bunch of y stuff, if it was written as g of y, you could call this g prime of y. So we're going to walk through some examples most of the arc length problems you're going to see are of two, let's say three varieties. Variety number one, you're allowed to use a calculator to find the arc length, which we're going to see here. Variety number two, you're not allowed to use a calculator, but it's because you don't actually have to integrate to solve the question, right? Like it's whether they ask you in the multiple choice to set up the integral but not evaluate, or whether it's a trick question where you need to use other information you have, but you don't actually have to integrate. And then the third category are going to be ones that you do have to integrate, but it's possible by hand. And that category is going to be very carefully designed because it's hard to, you have to set up an arc length problem very carefully to make it something that can be done easily by hand. So let's go ahead and walk through this. So I want to find the arc length for this curve from 1 to 4. Okay, so to do that, I know that the arc length is going to be the integral from 1 to 4 of the square root of 1 plus whatever my derivative is, quantity squared, with respect to x. So really, my job is to find the derivative. My job is to take this function, right, and say, oh, okay, cool. If y is x squared plus 5x minus 1, then my y prime or my dy dx, it doesn't matter which notation you use, right, y prime or dy dx, equals a 2x plus 5. So my entire job, right, what I need to do to get credit on this problem is I need to write is the integral from 1 to 4 of 1 plus 2x plus 5 quantity squared. Don't bother to clean it up. Nobody cares. And then I'm going to go ahead and integrate on my calculator. That's it, right? That's 100% my job. So it's up to you if you want to type in that 2x plus 5 as 2x plus 5 when you integrate. It's up. You could also put that in as your y1, right? You could put the derivative as 2x plus 5. So when I go to math 9, right, I'm gonna math 9, and I want to integrate the square root of 1 plus vars over to y vars, the thing I called y1 quantity squared, right? Because I called my y1 the 2x plus 5, comma, with respect to x from 1 to 4. And I'm not doing it by hand. That's my answer, 30.154, right? So this is what you would need on the AP, and this is what you need, right? They don't think it's cheating if you were able to do this in your head, like if you were able to, so if that's in your brain, nobody thinks that's cheating, okay? If it's a harder derivative, you might want to be a little careful. All right, let's go ahead and do another one. Same idea, we have this curve. We want the arc length from -1 to 2, right? So my arc length is going to be the integral from -1 to 2 of the square root of 1 plus whatever this derivative is squared with respect to x. So I need to find this derivative, right? So this, my y prime should be a 12x squared plus 4x plus 3, right? And then the 8 goes away. So I'm just going to put 12x squared plus 4x plus 3. You're not distributing this. You're not cleaning it up. There is no incentive on the planet to do so. This is what they need to see. And then you were told to use your calculator to find the value. So then you're going to say, cool, so S is approximately a thing. Again, you can make your life a lot easier if you just go to your y equals if you're doing multiple of these in a row, which obviously you won't necessarily be doing on the AP test, but you can make your life a little bit easier by just changing the value of y1, right? Quit out of this, and then I can hit second enter. There's my arc length formula, right? And all I have to do is change my interval to -1 to 2. And I get that this is approximately a 51.209 or 10, depending on what you're doing. All right. So E2, same concept, except this time it's in terms of y. It doesn't matter that it's in terms of y. We're going to behave exactly the same way. So my arc length, right, should be the integral from 0 to 3, these are y values, of the square root of 1 plus, and then I need to write the derivative of this thing, right? So I need to write whatever derivative of x with respect to y is squared with respect to y. So I need to find the derivative of this guy. So x prime, which is the same as dx dy, right, because I'm deriving with respect to y, is going to be 2e to the 2y, right? Because the derivative of e to the stuff is e to the stuff, and then I times by the 2. So basically, I'm going to get that this thing goes in here. So I'm going to see that this is the integral from 0 to 3 of the square root of 1 plus in parentheses 2e to the 2y quantity squared. Again, no incentive to distribute that, right? I'm not integrating this by hand. There's no reason to do that. Just leave it like this, right? The AP just wants to see that you get how it works. Now remember, I'm going to go ahead and call this x in my calculator, right? So even though it's a y here, I'm going to call it an x in my calculator. Sorry, e to the 2x. And then delete and double check it's right. So I'm going to go ahead and call it an x. I'm going to hit second enter. Right, that's my y1. I'm integrating with respect to x because, again, in my calculator, even though I know that it's a y in the problem, I'm using an x standing in for the y in the calculator, and I hit enter, and there's my answer. So I get 402.551, right? So the trick with arc length, and I think you're probably picking up on this, is if you know the formula, it's not that bad of a problem. If you don't know the formula, you're going to tend to get it wrong, right? This is a pretty quick thing if you know the formula. The arc length from 1 to 4 is going to be the integral from 1 to 4 of the square root of 1 plus whatever the derivative is, quantity squared with respect to y, because these are all y's. So I need to find the derivative of this. Well, dx dy, or if you want to call it x prime, right, doesn't matter. Derivative of cosine is a negative sign, right, negative sign of y, and we are deriving with respect to y here, so there's no dy dx, right, so negative sign, so this is a negative sign of y, right. So that's what I'm going to go ahead and put in as my y1. Right? So as my y1, I'm going to put a negative sign of x. I know the x is actually standing in for a y. Right? So I quit out of here. I hit second enter because I've already done all the work. Right? And then all I need to do is change the bounds from 1 to 4. Oh. Sorry, there's an extra parenthesis. So quit out of there. Second enter. And there we have it. So whenever you get an error and it gives you the option to go to, make sure you go to. It's probably something pretty obvious. And there's my work. All right. So let's do a tricky one. So remember, I said there are 3 kinds of problems. The first kind are kinds where you'll be allowed to integrate in the calculator. Boom, no big deal. You still have to do the setup by hand, right? But you can integrate in the calculator. The second are the kind where you're going to get something tricky, right? So you're going to get a tricky piece of information that doesn't actually require you to integrate by hand. So we are told that this is the arc length from 1 to 5. Okay, so this is the expression for the arc length. We are asked to give a formula for f of x given that f of 1 is 6. So in this formula, right, the formula should be the integral from a to b of the square root of 1 plus whatever f prime of x is, quantity squared with respect to x, right? That's what this should be. So what I want you to notice is that this thing has to be this thing. So what I know is that 9x to the 4th has to be f prime of x quantity squared. Well, that means if I solve for f prime, I can take a square root. So plus or minus a 3x squared. Actually, let's add the step just to show. So if I square root, I do plus or minus the square root of this thing. So essentially what I get is that f prime of x has to be plus or minus 3x squared, right? Has to be plus or minus 3x squared. Once I know that, there's 2 options, right? F prime of x is a 3x squared, or f prime of x is a negative 3x squared. Well, I have an initial value I can integrate to find f of x. There are 2 different options, which is what it said in the problem. It said there are 2 possible options. So if I integrate f of x should be an x cubed plus some c. I was told that f of 1 was maybe a 6. Yep, I was told that f of 1 is 6. So 6 equals 1 cubed plus c. I think I get 5 is this c. So the one option is f of x equals x cubed plus 5. Great. Okay, that's one option. Or the other option is, if I integrate this one, I get f of x equals negative x cubed plus, I'll call it c sub 1 because it's a different c. I know that f of 1 is 6. So 6 equals negative 1 plus c, looks like, plus c sub 1, looks like my c sub 1 must be 7. So the other option is f of x is negative x cubed plus 7. So in all likelihood, it's possible you'd see this as a free response and you'd have to do what I just did, where there are 2 possible answers, right? There's 2 possible equations, and you're giving both. What's more likely is you'd see this as multiple choice, and one of them would be an answer and not the other. If I were doing this on an AP as a multiple choice, I would give you the green answer, not the blue answer, because I think the most common mistake in this problem is people would forget this plus or minus. And if you forgot the plus or minus, you would get the blue answer, but you wouldn't get the green answer, right? You wouldn't see the negative. So just to put that out there. So that's a tricky problem, but notice it didn't actually ask me to integrate this ugly integrand. I didn't have to do that. So remember, that's a whole separate category of these arc length problems are where you're not actually asked to find the arc length and solve, but rather where you're asked to infer things from information that you're given. All right, so let's go ahead and do one more like that. We'll do a P3, and then we're going to do the one of each where you're actually able to integrate by hand. You're not going to see a ton of those, but they do happen. All right, so same situation. We have some g of x. This is the arc length. I know that this is the arc length from A to B. This should be 1 plus g prime of x, quantity squared dx. So what I need to get from this information is that this thing is g prime quantity squared. That's the leap that you have to make. So 25 over x to the fourth is the same as g prime of x quantity squared, right? If I square root that, I need a plus or minus. So I'm going to get that g prime is plus or minus 5 over x squared, right? And obviously x can't be 0 because that would cause an issue, right? So now I have two possible answers, right? So either g prime of x is a 5 over x squared, which is the same as a 5x to the negative second, right? Or g prime of x is the negative of that, negative 5 over x squared, which would be a negative 5x to the negative second. So now I'm going to go ahead and find both answers. If I integrate, it is worth noting that g of 1 is 2, so we'll need that in a second. So if I integrate this, right, when I integrate, I raise the power by 1 and divide by the new power. I'm going to get a negative 5x to the negative first, or a negative 5 over x, plus some constant c, and I'll just call that c sub 1. I know that g of 1 is 2, I believe. I am going to scroll up and just triple check. Yeah, there we go. Okay. So if I plug in 1, I'm supposed to get 2. So 2 equals negative 5 over 1 plus c. I'm pretty sure my 7 is that c sub 1. So the first option for g of x is a negative 5 over x plus 7. The other option, right, is the same situation but with a negative. So I'd get there's a negative in front here, which means when I divide by the new power, it becomes a positive 5 over x plus, let's call it c sub 2. We know g of 1 is a 2, so 2 equals 5 over 1 plus c sub 2. I think I get a negative 3 as my c sub 2. So the other option for g would be 5 over x minus 3. All right, and those are my two options. And again, the trick to that problem is a lot of people would forget the plus or minus and would only answer one of them. I think this would be more likely a multiple choice question. All right, so most arc length problems are one of the two categories that we just saw, right? You either set it up and can integrate on a calculator, or you're setting up without integrating, which can also kind of fall in that idea of using a trick problem. All right, so we're going to walk through two problems where we do arc length by hand. So we're going to set up the integral expression for the arc length of this curve between 3 and 8, and then we're actually going to integrate by hand and check on the calculator. So remember, you might as well write out the formula for the arc length because you know what it is even if you don't know what the derivative is yet, right? So we're integrating from 3 to 8 of the square root of 1 plus whatever my y prime or dy dx is, quantity squared with respect to x. So really, I should start by finding my y prime or dy dx, right? So dy dx, or y prime, is going to be, I drop the 3/2 down in front, and it cancels with the 2/3, and I get x to the 1/2, or a square root of x, right? So I'm going to integrate from 3 to 8 of the square root of 1 plus, when you square root and square at the same time, they cancel. So I'm going to get that this is the integral from 3 to 8 of the square root of 1 plus x dx, right? So this is fairly basic u sub. If you want to cheat and just do the work, so I'm just going to do the u sub work without bounds, right? So I'm going to do the work without the bounds. And you could probably do this u sub in your head, but the u is x plus 1, and that makes the du just dx. So basically, this integral becomes root u du. So this is going to become a 2/3 u to the 3/2, right? That's what we need. So when I come back up here, I get that this is a 2/3 1 plus x to the 3/2 evaluated from 3 to 8, right? So I'm going to go ahead and get, so that's what I got from the work that I did to the side. I'm going to get that this is a 2/3. So this will be a 9 to the 3/2. minus a 2/3, and this will be a 4 to the 3/2. So sometimes these numbers turn out nice. In this case, 9 to the 3/2 and 4 to the 3/2 both turn out nice. So just as a side note, if you're having any trouble, sorry, I want to switch colors. If you're having any trouble with these numbers, right? Um, so let me give us a little room down here. 9 to the 3/2 can be done in one of two ways. There is a way that's easier mathematically for people without a calculator. So 9 to the 3/2 is the square root of 9 cubed, which would be a 3 cubed or a 27, right? This is good, right? It's much harder in your head to do 9 cubed and then square root it, right? It's possible, but this is bad for mental math. It's not that it's wrong, but it's just bad for mental math. You will also still get a 27, but you have to know what 9 cubed is, and then you have to know how to square root it, and it's just not a great idea. By the same token, 4 to the 3/2 is easiest as a square root of 4. Sorry, we're beach balling for a sec. Quantity cubed, which is going to be 2 cubed or 8. 4 you actually could do either way because most of us know 64 and can square root of 64 and also get 8. So it doesn't matter which way you do it. I'm going to yank out the 2/3 and make this a 27 minus 8. So I'm going to get that this is a 2/3 times a 19. So I get 38/3 as my final answer, right? So my answer, if I come back up here because I'm low on space, my answer would be 38/3, right? That would be my answer. And then I can check that by going to y equals and putting in my root x as my y1, right? Quitting out, I'm going to go ahead and do math 9, right? I want the square root of 1 plus the thing I put in as y1, because that's the f prime. Sorry, close that root, comma, with respect to x from, I believe it was 3 to 8. Yep, that's right. And hit enter. And then I'm going to go ahead and math frac. And there's my 38/3. Okay. Again, these have to be really carefully constructed. So let's go ahead and try another one. Again, notice it's not an accident. We already had an x to the 3/2. You have another x to the 3/2. It's definitely not an accident. They have to be very carefully constructed problems. So my arc length is going to be the integral from 0 to 5 of the square root of 1 plus, and then the thing that's going to go in here, right, that's my y prime squared. So my y prime is going to be 3/2 x to the 1/2, right? So y prime squared should be a 9/4 x, right? Because this is a 3/2 root x. So I'm going to get that this is a 9/4 x, right? When I go to integrate, this is going to be u sub again. It's a little bit less straightforward this time because my u in this example is going to have a 9/4 in front of the x. So my du is going to have a 9/4, right? What that means is that I'm going to get 4/9 du to replace my dx. So this is going to be the integral of root u times 4/9 du. There's basically going to be a 4/9 in front of this thing. So I'm integrating root u du, but with a 4/9 in front. So that's going to be 4/9, right? And then when I up the power by 1, it's going to become to the 3/2. So this is going to be u to the 3/2, and I'm going to need to divide by 3/2, which is the same as timesing by 2/3. So I should get 8/27 u to the 3/2. That's what I'm going to get when I integrate. And again, that's my work without bounds. I intentionally segregate it because I didn't feel like changing my u value, right? So what's going to happen here is I'm going to get that this is, what did we say, 8/27, sorry, it's not a u, 1 plus 9/4 x to the 3/2 evaluated from 0 to 5, right? So when we plug this in, super good times. I would probably yank the 8/27 out because there's no reason that I shouldn't do that, right? I yank that out, and when I plug in a 5, right? Well, honestly, it might be easier to get a common denominator here. So I'm probably going to make this a 4 plus 9x all over 4, right? Because I could make this a 4 over 4. So when I plug a 5 in, right, I'm going to get 5 times 9, which is 45 plus 4. So I'm going to get 49/4 raised to the 3/2, which we'll deal with in a sec. And when I plug in a 0, I'm just going to get a 1 here. So I'm going to get a 1 to the 3 halves. Good times. So seems to me that I get this 8/27, and then let's go ahead and talk about what the 49/4 to the 3/2 is, right? Remember, the easy way to do 49/4 to the 3/2. So if we come down here for a sec, right, let's just do 49/4 The easy way to do 49/4 to the 3/2 is to do the square root of 49/4, which is easy because they're both perfect squares, and then cube it. Well, that's going to end up being a 7/2 cubed, right? Which is not super fun, but so I'm going to end up with a 7 cubed, which is probably 343. Either way, I'm gonna leave it as a 7 cubed for right now over 8, right? And I'll deal with it, but I'm gonna leave it as a 7 cubed over 8 for right now because that's fine with me. We'll deal with 7 cubed in a minute. So I'm gonna leave it as 7 cubed over 8 minus a 1, right? So if you had a calculator, then you would figure out what 7 cubed is. If you don't have a calculator, you would literally do 49 times 7 and it wouldn't break your brain. You'd be fine. If I did 49 times 7, old school multiplication wise, I think I get 343, but we'll find out in a sec. This is a 6, right? When I multiply these, I get a 28. And hey, sure enough, there's my 343. So I'm going to go ahead and say, hey, this is 8/27 times, this is a 343 minus 8 because I wanted everybody over 8, right? So I think I get 335. And then the 8s are going to cancel. So I think I get 335 over 27. And I think that's my answer. 335 is not a multiple of 3, and 27 is only 3s if you look at how it factors. So we're going to see, but that's what I think I get as my answer. So I think that's my answer. Let's find out. So when I go to put in my value here, right, so this is going to be a 3/2 in front. So I'm going to go ahead and, quit out of that. So I'm going to second insert either 3/2 or 1.5, doesn't matter to me which, right? And then I'm going to quit out. And then I'm going to hit second enter. And the only difference here is the bounds, so 0 to 5, right? I hit enter, and I'm going to math frac. And hey, look, that was tedious and awful, but we got the right answer. All right, so that's arc length in a nutshell. If I have the time to do it, I'll make you another quick video about a time that I legit used arc length and some calculus in my real life, not a made-up story, an actual thing that happened. So, but that is the end of Unit 8.